Alright, I'm Christopher Owen, and this is my decision tree code demonstration video for CS4242 Artificial Intelligence, Section 01, Fall 2016 at Kennesaw State University. So my approach to writing the program began with creating the breadth first search and the depth first search, and then writing the XML parser afterwards. To start implementing the two searches, I first needed a way to build the tree. I decided on hard coding it, my decision tree in a method called build tree. Where is it? Right here. I decided on hard coding it that way in this method build tree and would leave it that way until I finished all my searches. From there, I created a separate node class, which could get and set a node's ID, the behavior, response, and parent node. Going back to my decision tree class, I then create a method called addChild, which would create my nodes for me. Using addChild, I added all the nodes from the original XML data files without parsing inside of my build tree method. For my BFS and DF searches, I used a queue and a stack respectively, a queue for BFS and a stack for DFS. Each of these searches calls a pick response or pick random response right here to set a random value, and then determines a random response node to find which both of these searches, a random response node defined, which both of these searches must find. As each of the respective searches run, it takes into account the amount of steps, like up here in steps, and then sets the steps for each search to two distinct variables right down here to steps, step BFS and step DFS. Finally, it is all brought together in the search event method, which uses a scanner to allow the user to input a specific behavior to search for a response. Calls are two separate searches, BFS and DFS, right here, BFS and DFS, and determines how many steps it takes for each search to find a response, and then finally prints out the steps it took to find each response, like I said, called item. Once I had completed my two searches, I moved on to making my program able to parse in the XML file provided. I began, of course, by simply copying the provided XML into an XML in my project. I then created two methods, right here, the load tree method, the load tree from file, and the parse line to deal with the XML parsing. My load tree from file method reads in the XML file and also calls my parse line method. The parse line method is pretty much where all the actual work happens, as it establishes what each line is. To be more specific, the parse line method utilizes four if-else cases to run lines of the XML through to determine whether the specified the parse line method utilizes four if-else statements to run lines of the XML through to determine whether the specified line is a root, a node, an end node, and an end root, and then applies the node's necessary attributes. While it passes through lines of the XML, it also makes sure to add the previous nodes to the stack. I define a stack up here, parent node stack. While it passes the lines of the XML, it also adds it to the stack and applies the stack's top node as the current node's parents. Once the XML parser hits an end node or an end root, the top node is then popped off the top of the stack, right down here. Making sure that the parent-child relationship with the nodes are kept current. At that point, I was able to build the tree without the old build tree method, and everything started working properly. So I'm going to give you an example of it running. As you can see, it built the decision tree properly. Let's do incoming projectile. And there you have it. Thanks for watching.